Well, g'day everyone. I haven't done too many local videos recently because it's been a hell of a week. Had some tree branches come down the house, and that wasn't all that fun during that last storm. So anyway, getting back into it. Nothing boring stuff. I just wanted to do a small cap on sidereal days, because I believe that this is one small piece of the puzzle when it comes to defining as to whether or not the Earth is moving. A lot of people like to go out there and say that the Earth is moving. You can't prove it, you can't feel it, blah 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 blah. But sidereal day is a piece of the puzzle which does indicate that something strange is happening out there. Now, the sidereal day is measured by picking a particular distant star and then waiting for that time to come back around until it's aligned dead on side again. And that time usually takes 23 hours and 56 minutes and 4 seconds. And you get that extra 3 minutes and 56 seconds where it continues to turn towards the sun, where it becomes the solar day, and that is what is considered the 24 hours. So 24 hours is when we strike the sun and then come around and strike the sun again. But sidereal is when we come around from a particular star and we come around and see that star again. Now, what this means is that we see the stars move faster than what we would see the sun. If the Earth was going in the opposite direction, if it was flying out to the left, I would imagine that we would get the sun appearing faster each day and the stars slower. So that's a shout out to Leslie, who seems to believe that the sun is faster than the stars. But in this particular instance, the way we're traveling, the stars are moving faster than the sun because they reach the target at 23 hours and 56 minutes, whereas the sun reaches 24 hours. So this is the basics on sidereal time from Wikipedia. I know that people don't like Wikipedia that much, but the items in here they're accepted means. And when you look at this particular diagram here, our planet, when it rotates 360 degrees exactly, that's the sidereal day. That's when you're roughly aligned with the star. Keeping in mind that obviously stars do move as well, and if they are many light years away, they've obviously moved from the time that they were first sending that piece of light. Because if a star is, say, 7 light years away, then that means that star emitted that piece of light 7 years ago. It's traveled all the way to us, and we've only just caught up now. We don't know if that star has moved a couple of mil to the right or left, because it's taken 7 years for that light to hit us. Now, when we reconnect with our solar day, which is that 4 minutes extra, and that's we rotate at 361-ish degrees. Now, I think it is probably a little bit lower than that. It would be probably 360.95 or something like that. So just generally 361 is fine. It says actually over here, Earth rotates 366 times per a normal 365 day. So that means that we've got one full extra rotation in there because of this variation here. Now, I wanted to sort of show how this works from the Excel document. And I know I don't like looking at Excel documents on videos. I absolutely hate it because a lot of people have embedded a whole bunch of information they're not willing to tell you, and then they say, there you go, all the charts, you can't read it, you can't see it on the screen. But this one's simple, so it shouldn't be that hard. All I've really done here, 24 hours times by 60, you got 1,440 minutes, times by 60, you've got 86,400 seconds in the day. That should be pretty easy. I'm sure everyone can do that on calculator. The sidereal day, we've got 23 hours, 56 minutes, and 4 seconds. Now, just so to make it easier, I've broken it down to these areas here. So that's how many seconds are in 23 hours, that's how many seconds are in 56 minutes, and how many, 4 seconds for 4 seconds. That totals 86,164. So that's how many seconds is a sidereal day. This is how many seconds in a solar day. And punching those two numbers together, you get a difference of 236 seconds. Now, I would be surprised personally if there's even higher decimal degrees to that, but that's fine for now. So the sidereal seconds, as I said before, 236 seconds. Now, if you times that by the 366 day cycles, actually, we'll change it from cycles. 366 cycles in the year. Now, 236 times 366 equals 86,776. So as you can see, the amount of seconds you get when you add all of these sidereal differences together for 366 cycles equals a similar time to 1 day of seconds. So that's a roundabout way where this 4-minute difference is basically saying that every single day we are, I think, we're losing 4 minutes per day, I believe. I might have to be checked on that. I'm probably gonna, if anyone writes in the comments, I'll probably end up wrong. But I believe that we have lost 4 minutes every single day to the sidereal day. And when you compound those 4 minutes by the amount of days or cycles in the year, that's how you come back to this. And that's kind of in the grand scheme of all this. It makes sense that every single day you crank it just that 1 degree a little bit more each day. I mean, if you think about the fact that the Earth's rotation right here, we have to do 360 degree to do a turn, and the amount of days is 365. They're so close. I mean, 360 versus 365, it's like a micro percentage of difference, and so we increase. We rotate that 1 extra degree every single day for 366 times, and we will end up back at that same sidereal alignment 1 year later. So this is a factor which I believe is one piece of the puzzle to say that we are moving around the sun. And this ties in with the stellar parallax and stuff like that, because there are times when the sun is in, it's directly in front of Orion's belt, like I've said on previous videos. And then there are times when the sun is on the complete opposite side of Orion's belt. And then that 6 months later, we're back, the sun is directly in front of Orion's belt again. So that is all puzzle pieces. You can't go out there and say this one thing solves all questions. You need these puzzle pieces. You need the fact that Orion's belt appears behind the sun sometimes, and then it appears to the opposite side of the sun. You need the sidereal day times, the 4 minutes difference each time. What else do you need? You also need, if you had a gyro and you ran your gyro for 24 hours, if you got to run it for a full 365 days, you'll be able to increase your accuracy and find out whether or not in the 24-hour cycle, whether or not that gyro went 361 degrees or 360 degrees. If it goes 361 degrees and the amount of cycles, you multiply it to 366 cycles for the full year, you'll be able to further refine and find out whether or not that means that gyro has tracked its variance all throughout the year. So these are all puzzle pieces. You can put them all together and it tells us whether or not we are rotating around the sun and whether or not we're rotating at all. So these are all factors, and so whenever Whitsitt goes, nah, you can't prove that. All he's doing is poisoning well. He's just poisoning the well, which is one of the things he doesn't like us doing. But effectively, if he says you can't use that as an excuse, all these factors are something that you can go out there and use. And the other degrees that I was talking about where it comes to proving whether or not we're going around the sun, Mercury does not spin around us. Venus does not spin around us. Mercury and Venus both go in a sort of a zigzag to the left and to the right of the sun, and they never go around the back of us. Mars goes around the back of us. Saturn and Jupiter goes around the back of us, but Venus and Mars kind of wiggle left and right from the left hand side to the right hand side of the sun like this. They wiggle like this, whereas Mars goes around over here and comes back over here. That is all indications of heliocentrism and the movement around the sun. Now, the grand scheme of the sidereal day, all right, is why do we even have a sidereal day? This is the big final question, right? Because when I was in that argument with Whitsitt one day, he said that is just some sort of dynamic whatever, I can't even remember. He said it was some sort of dynamic variance or some sort of shit. But the truth of the matter is, and I'm going to finish with that, is sidereal time is completely meaningless on flat Earth. There's no reason why sidereal time even needs to exist. The sun could be equalized. It could be completely 100% synchronized with the stars. There's no reason for sidereal time to even take place. Sidereal time only makes sense for a globe Earth. On a flat Earth, it's just randomization. There is no meaning to sidereal time. It's just randomization. So that's my final answer. All right, good night.